Hello friends, welcome to my third session in kinematics, and today we are going to cover triangular law of vector addition. In the last class I covered the parallelogram law of vector addition, where we saw how two forces can be resolved and you can get the resultant force. Now triangular law is a very simple law. I'll just explain this now. Let's assume that we have a body here and it is acted upon by three forces, let's say F1, F2 and let's say F3. Now all you have to do here is, let's consider this as segment 1, segment 2 and segment 3. So what you will need to do here is, you will need to take these individual forces and draw them from tail to head. So what that means is, let's start. So let's redraw this. Let me explain this. So let's draw the first force here. First force, this is the tail of the vector, and this is F1, right? So this is the tail part and this is the head part. Now the second force, so this is our first one. The second one is F2. So what we need to do is begin from the head and draw F2. So this is F2 now, and this is our second segment. And the third segment, again begin from the ending point of this vector and go along the direction. This is F3 and this is our segment 3. Now once this is done, what you find is that this is where you started and this is where you ended, right? Now, so what is the resultant now? The resultant is nothing but this. This is the resultant. This is how simple the triangular law of vector addition is. So now, if you remember in our last class, when we took up two forces, if you remember this example, when I demonstrated the parallelogram law of vector addition, if you remember this is how our forces were, F1 and F2. Now suppose we use the triangular law. What we will do? Let's draw it. So this is our segment 1, this is our segment 2. So what we'll do is draw the segment 1, F1, this is segment 1, and the second one is from the ending point of F1, go this way. This becomes your F2 segment 2. So you see your resultant. So this was your starting point now, and this was your ending point. So your resultant is, this is your resultant. And this is exactly, if I were to do it by the parallelogram method, what I would have done is, I would have completed the parallelogram like this, and the resultant would be this. So let me show it to you in a different color. So now this is, when we used the parallelogram method, this was the resultant, and when we used the triangular law, this was the resultant. And you see, both of them are exactly the same. So this is how simple the triangular law is. Now you may ask me, how will I solve problems now? What I explained to you is the graphical method. Now I'll give you an example. So typically what happens is, in your exams, what will happen is, I'll give you an example. Let's work this out with an example. Let's say that this is a body. You have a force of 5 newtons in this direction. You have a force of 4 newtons in this direction. And let's say you have a force of 10 newtons in this direction. And a force of, let's say, 2 newtons in this direction. Right? And each one is at 90 degrees. So how will we solve this? So let's mark this as, let's take this as segment 1, this as segment 2, this says segment 3 and this says segment 4. Let's go. So let's begin with segment 1 now, right? And always remember, when you do a freehand drawing, it's always a good idea to have some kind of understanding with reference to the numbers you're writing. For example, if I'm representing 10 newtons by this length, and if I have to represent 5 newtons, it's better to represent it with this length, right? So if this is 10, this is 5, and if I have to represent 2 newtons, I'll probably do it this way. This may be 2 newtons. So this is only for freehand drawing. Now, so this is the right way. Now suppose you take this as 10 newtons, right? And if you are going to draw 5 newtons like this, right? What will happen is, when you do your freehand drawing, it might misguide you. So it's better always, even when you're doing freehand drawing, put some meaning into what you're drawing. Now let's find out the resolution of this. Right, so let's draw segment 1 first. So segment 1 is 5 newtons. So we draw 5 newtons. This is segment 1, and 10 newtons. So 10 newtons is approximately double. So let's do it. So let's make this a bit smaller. Let's make 5 newtons so much, so that 10 newtons can be represented double of this, which will be approximately so much. So we'll call this as 10 newtons. This is our segment 2. And then we can come to segment 3, which is 2 newtons. So 2 newtons would be a small part of this. So this is our 2 newtons. Okay, and this is our segment 3. And our final one is 4 newtons. So that would approximately be so much. This is 4 newtons, and this is our segment 4. So this was our starting point, and this was our ending point. So what will be the resultant? Our resultant will be so this will be our resultant. Now if you see, all these are triangles, right? You have a right angle triangle, so it's very easy for you to measure this distance. So for instance, how will we do that? If this is 10 meters, this is 2 meters. So if I can, this is by simple geometry. So if this is 2 meters, if I extend this downwards, so this part will be, this will be 5 minus 2, that will be equal to 3 newtons. So this part is 3 newtons. And what is this part? So if I can draw a line, so this represents 4 and this represents 10. So this part from here to here will represent 10 minus 4. So that is 10 minus 4. This is 4. So this part will be 6 newtons, right? So we have 6 newtons here, we have 3 newtons here. So as you see, now this particular problem has been reduced into finding out. So it's equivalent to saying that we have a problem like this now, right? This is the resultant. This is 6 newtons and this is 3 newtons. So by application of Pythagoras theorem, R equal to 6 square plus 3 square under root. So you can do the computation of it, and that will be your answer, right? So this is how it is done. So it's very simple. You don't need to get into too many complications. It's a very simple process. It mostly works graphically. So, but always keep in mind that when you draw your free body diagrams, when you draw with freehand, always ensure that you're making some sense into the drawing. So that's very important. So there's nothing more to cover in this particular triangular law. So I'll see you in the next class. Thank you.